Molarity versus stoichiometry for solutions. When am I going to use my molarity formula and when am I going to use stoichiometry? Well, stoichiometry is between two different substances of reaction, and the molarity formula will convert between moles, liters, and molarity for one substance. So let's look at 1A. How many liters of a 5.5 molar calcium hydroxide solution are needed in order to have 5.5 moles of calcium hydroxide? Well, I'm going between only one substance only, so that's conversions. I need to find liters. They give me molarity and they give me moles. What formula is that? That's my molarity formula. I rearrange it, so I'm solving for liters, and when I plug everything in, I get 11 liters of calcium hydroxide. B, find the number of moles of sulfuric acid needed to react with 5.5 moles of calcium hydroxide. I have two different substances. I'm going to use my mole island. Okay, so what am I doing here? Super simply, I'm going from moles of one substance to moles of another, which means I need to use my coefficients from my balanced equation. So I start with 5.5 moles and I need H2SO4. Now up here I labeled, so here's B, 5.5 moles, I should put moles there, and I'm going to moles, so I'm going from moles to moles. Okay, here's my path, moles to moles, and then where do I get these coefficients? From my balanced equation, 1 and 1. So I don't want moles of calcium hydroxide. I get rid of them by putting them on the bottom. I go to my moles of sulfuric acid, and then when I multiply that out, 1 to 1, I get the same amount of moles. Cool, simple. I can get C in one of two ways. Let's go with the easiest one that you might not have noticed, and C says if H2SO4 is 0.82 molarity, how many liters of it are needed to react with 5.5 moles of calcium hydroxide. I'm going between two substances, so it's stoichiometry, and I'll do the full problem next. But first, you may have recognized that we already did 5.5 moles of calcium hydroxide, and we got 5.5 moles of H2SO4. And now that I have 5.5 moles of H2SO4, how many liters of the 0.82 molar solution do I need? Okay, to get that 5.5 moles. And if I'm going from H2SO4 moles to H2SO4 liters, that's the same substance. That's my molarity equation. I have moles, they've given me molarity, and I need to solve for liters. I rearrange it, and I get 8.71 liters of H2SO4. Now, if you didn't recognize that was a continuation, we can do our stoichiometry, because I'm going from moles of calcium hydroxide, and then they want me to find liters of H2SO4. Okay, so I'm starting right here with moles of calcium hydroxide. I need to go to moles of sulfuric acid, and then I need liters, which is my volume of liquid, not gas, and I'm going to use that molarity formula. Okay, so my path is moles of calcium hydroxide to moles of H2SO4 to liters of H2SO4. And up here, I labeled C. This is 5.5 moles, and I'm going to liters, okay? So we have our path, and just like we did up here, I'm going to get rid of my moles of calcium hydroxide and go to moles of H2SO4, and that's going to give me that. Now, I can then plug that right into the equation like I did here, or if you want to keep going with your string, 0.82 molarity is 0.82 moles per liter. So I can use dimensional analysis and do it this way, which means I could have left that out and done this all in one string. Okay, and then you still get the same answer that I did up here, 6.71 liters of sulfuric acid.